Good afternoon, everyone, and welcome to Layer by Layer, the show about 3D printing and our place inside the industry. Today, we're going to be talking about BMW printing hundreds of thousands of parts, some updates over at Align Technology, and what we have as far as updates on the Tangled testing YouTube channel and data collection project, as well as several key updates on Tangled itself, finally culminating in the discussion of why we're not dead yet. But before that, let's go ahead and pay the bills. This episode is brought to you by Tangled Filament. Tangled Filament is our attempt to reduce the cost of 3D printer filament down to $10 per kilogram. We're doing that by optimizing the cost of filament and doing everything that we can to just not waste resources in the production of filament. So far, we've gotten it down from $22 down to $15 a kilogram, and you can get a hold of that today. You can order it in packs of 3, and you can have any color you want, so long as it's black. So go ahead and check out tangledfilament.com. But yeah, Tangled's available right now. Right now, we're about, if you're ordering, like right now when this podcast comes out, your orders should ship in about 3, maybe 4 days. We had a backlog before, so if you ordered before this podcast, they might still be processing because we're just coming to the tail end of that. That big old burst from a week or so ago. So we're getting caught up on that, and we've restructured and re-leveled up again now to where hopefully we hold at this lead time until the next big old update in production. But we'll get into more of that here a little bit later on. First of all, let's go ahead and get into the first piece of research. Researchers from Seoul National University have developed a new two-step process for FDM 3D printing that can create parts with specific gradient material properties. So this is an interesting research paper that came out. Basically, they are 3D printing filament, and then you run that filament through another 3D printer. It is set up for desktop machines, but what they did in the research paper, it's a demonstration. As a research paper, it's just a demonstration of the tech, but they literally have a desktop machine. They run through a particular set of material. In this case, they use TPU and highly carbon-loaded PLA that was conductive. But they basically lay down a bead of TPU, and then they lay down a bead of the carbon black, and then TPU again, and so on and so forth, effectively building up a line of filament, a coil of filament on a printer itself. But you're able to minutely adjust the material properties of that filament because you can have a single bead of this and a single bead of that in only a certain area. You can three-dimensionally control the different materials inside the filament. Then when that filament is run through the machine again, you are very precisely controlling the resulting part. Now, this is a nifty concept. In practice, it'd be super hairy because you're 3D printing filament, which is not the most cost-effective way of making filament, so it doesn't really have scale. But if you want to develop the technology a little bit more to create very specific types of parts that have very specific functions, like integrated conductivity and very varied properties, it's a way of doing it. I think there's a lot more power in other areas of 3D printing that haven't been utilized, like just the changing of the macro structure of the part itself. That's still not utilized enough inside of 3D printing. So this is great, but it's very, very early. And I personally don't see the applications of it. I know that there's definitely some out there, but I don't see why this research paper would be picked up to be put into production or put into commercial use. BMW Group says it has produced more than 300,000 parts with 3D printing at its additive manufacturing campus in Germany last year, with a further 100,000 produced across its global production network. The German automaker has been using additive manufacturing technology since the early 90s for everything from concept models to end-use parts. The increasing use of additive manufacturing in the BMW Group production system has many benefits, says Jens Ertel, head of BMW additive manufacturing. For example, we are able to quickly and economically and flexibly produce our own production aids and handling robots, which we can individually adapt to specific requirements at any time, as well as being able to optimize their weight. Less weight allows higher speeds on the production line, shorter cycle times, and reduced cost. Plus, smaller robots can be used in the medium term, which also cuts CO2 emissions and costs. That's all great. I'm going to call a tiny little bit of BS on the CO2 emissions because lightweighting of a robot in effector, yes, it reduces energy consumption. And if you're producing millions of cars, that's not nothing, but it's not huge something. Anyhow, but the value in sped up production times, lightweighting the robots so they can move faster is all a big deal. Most of these pieces that they have made are very likely end of arm tooling and jigs within the factory. BMW makes a lot of cars. They make a lot of cars, but all the robots, that kind of thing, being able to custom design those end effectors and produce them and center them and lay them out, it effectively replaces machining. And is a little bit more efficient than machining. It's also a little bit faster and more flexible, especially as machinists get harder to get a hold of, especially in places like Germany. But the company recently shed light on its use of 3D printing for customized lightweight robot grippers at its Lightweight Construction and Technology Center in Landshut, where a particularly large gripper element used on a press in the production of all CFRP roofs for BMW models can be produced in just 22 hours and weighs roughly 20% less than a conventional alternative. Yes, so 3D printed parts, much lighter weight parts, way faster production of them because they're complex geometries that are tough to machine, a lot less assembly, all those things. So this is a classic example of production of this. It's not a ton of parts. And I know in 3D printing, we're impressed by 100,000. We do that here. I'm sorry. It's not interesting to me anymore. But it's great to see that and that the large organizations are absorbing that. If you are an organization that is looking for end-of-arm tooling or need tools, jigs, and fixtures within your factory, reach out to Slant 3D. We're really good at that stuff. We could actually probably even build you like an app specifically for your company where you guys could just upload the file and have the print delivered in a couple days or something like that. Our dev team is standing by to be able to help with that. I didn't expect there to be 2 ads in this with a story, but whatever. Line Technology has appointed Emery Wright as Executive Vice President of its direct fabrication manufacturing platform, effective immediately. Wright will transition his current responsibilities for global operations, which includes treatment planning and focus on scaling Align's next-generation direct fabrication, working in close collaboration with Srini Kaza, who has been promoted to Executive Vice President of Research and Development. Several other folks joining the team. The restructuring will see Wright lead Align's efforts in direct 3D printing of Align Technology products. Align Technology has leaned on 3D printing for the manufacturing of its aligner molds for more than 20 years, partnering with 3D Systems to enable the production of hundreds of thousands of aligners per day. Yeah. So 3D Systems has been producing the machines that 3D print the molds that Align uses. So you print out a bunch of molds of folks' teeth, and then you vacuum form the aligners over them. That's great, and that's a good way of doing it, and aligners are fully custom product. 3D printing is perfect for this. I did not know they were using 3D Systems, but good to hear that they were. Smile Direct Club, I think, was using MJF machines for the most part. But hundreds of thousands of aligners a day. Now, aligners are small little parts, so they have these big old vats of things knocking these out, and then they shake them off and then run them onto the assembly line. It's actually, I think there is an assembly line video of either Smile Direct or Align Tech showing how this is done, but they have never printed the aligners themselves. They're trying to get into that. Organizations like Carbon and EOS and a number of others have been working on tech for printing aligners directly. I think even Nexa has been doing this or working on this. And it's the one part of the industry that is making money still. Dental aligners still need this, and they're a great example of needing to use this. And Align Technologies is one of the few direct-to-commerce brands that still exists right now. Invisalign, by the way, if you don't know them. But anyhow, yeah, this is a great example of both scale and high customizability where 3D printing really shines. High customizability works, again, if it's very heavily formatted. These aligners follow a very definite sort of format. So even though you're changing the alignment of teeth and that kind of stuff, aligners are not as high variation as some things you can do with printing. Like, for example, we may print an arm cast in the morning and we may print a keychain in the afternoon, and those are totally different problems. But anyhow, that's the news. Alrighty, so moving on to other things. Tangled updates. So for Tangled updates, Few things. Like I say, we're getting caught up, so lead times will be reducing. Here by the end of this coming week or so, we should definitely be back up to shipping orders almost immediately as soon as they come in. So that'll be a whole lot faster. We do have a shortage of spools, and the suppliers being a little bit slow getting us stuff. So that might cause a fresh snafu. Fingers crossed that all those things are delivered this week, but we don't know that for sure. Okay. But yes, we're having some issues with spools. After these sets of batches, we had part of the cost savings that we did on the last several batches was the fact that we've been recycling spools. We've been the reuse spool program. That was great. I thought we communicated that all very continuously, as it was the last price break that we had done was using reused spools. And they were consistent enough and working well enough that we integrated them into it. But quite frankly, not everybody likes that. And I understand that because reused spools are an inconsistent format. It's more cost effective and you get cheap, affordable filament. But number one, we can't source enough used spools to keep up. And number two, it's inconsistent. So within our long-term goal of really creating a raw material feedstock for print farms, it has to be very consistent and very reliable, which means the spools have to be the same size all the time. So even though the recycled spools are a good way of reducing cost here in the short term, they weren't sustainable long term. So they will be going away. That being said, for 1 kg spools, spools are expensive. Quite frankly, the cost of a single kilogram spool is about the same as the cost of a 3 kilogram spool. And there's a difference, but it's not terribly significant as far as like baseline cost of the two of them. So it's possible that adding in these spools will maybe add a little bit of cost to the 3 1 kilogram sets. Just because, spool costs are there, and the spool costs are not necessarily cheap. We have not hit a scale to where we can really command good pricing on that. We'll keep on shopping for suppliers, but quite frankly, we've talked to all of them, and there's not really a big break on that. We may look back into manufacturing our own spool again, but people don't like that because, quite frankly, almost everybody uses the Bamboo Labs AMS, or a bunch of people do. And you cannot use our original octagonal spool. So we can't use that. I don't want to make round ones. People don't like cardboard, so you're stuck with plastic, and plastic's expensive and wasteful. So we're just kind of caught between a rock and a hard place. Though, we're not ready to announce this yet, but we will have a spoolless option at some point. On whiteboard right now. It'll come down the pipe at one point. So spools won't be here for forever. Right now though, I wasn't supposed to talk about spoolless. What the heck? Let's talk about spoolless. I don't care. But with spoolless, we're working on it. It's not ready yet by any means, not even close. But if we get it done, I think we'll be the only U.S. manufacturer actually making spoolless refills. Certainly at this price range. We will also probably do a redesign of the spoolless spool that everybody can print that goes along with spool holder on the site, by the way. But a spoolless, a new spool based on the Slant spool design, which quite frankly is still better than all the master spools out there. And then we will, so we'll have spoolless out there. Spoolless might activate a new price break, but spoolless is also higher labor, so we're going to see how that shakes out. But we're working on it. Should have spoolless at some time in the future. Okay. But working to reduce lead times. Like I say, we've been in a backlog for a minute here. We've been trying to stay ahead. Right now, you're kind of pre-ordering filament, and then we ship it when we're able to ship it. The lead time right now is about 1 week, 7 to 10 days-ish. And then we will, but we're accelerating through that backlog. We're about over that hump of big high demand spike, and then we'll get this long tail caught out, and then we should be caught up. So Tangled should be shipping more quickly pretty soon. Okay, software updates. The Etsy application keeps on improving. We've been revamping a bunch of new. We've been revamping it a bunch, and continuing to monitor it, and it's improving and it continues to get better. I'm very proud of the team on the Etsy project with how quickly it has improved, especially over the last couple of months. Orders are accelerating. All the things are good. We're improving quality on our side. We're going to start introducing new additional features to it here pretty soon. So colors should be available here pretty soon. That has been enabled also by upgrades to the API. And the API, the developers for the API, we will be doing a few, we're probably going to do a webcast of some kind, or a group chat, group Zoom. There we go. That's what I'm trying to get to. Of the developers who are in the Discord right now, which would be me, probably one of our other developers, to just talk to everybody about their projects, because we want to help you all work on those, to make sure that we're giving you what you need, to make sure that that's all as powerful as it is. In addition to that, as Etsy and the API have been scaling up and people have started using it, we've also been doing a revamp of our internal production software called Kraken. And Kraken is starting to hit its stride as well. So a lot of things are starting to spiral up and ramp up in a lot of good ways. So that's been fantastic, and props to the team on that, because we're starting to see real good improvement on that. We're getting past the MVP phase and starting to get into a good product roadmap and product improvement. The Etsy application is still really significant in how much it helps people. Do check out all of our other videos on that kind of thing. We don't need to go into it right now, but anyhow. Tangled testing. Tangled testing is going to start ramping up here. We just got our Tensile testing machine in about a week ago. We got it proven out last week and have started running tests. So videos of that new machine will be coming out pretty soon, probably both on this channel and on the Tangled testing channel. But that will start yielding some really good data just around 3D printed parts in general, because no one's ever done it. And this was the whole point of Tangled testing. Tangled testing was meant to quantify FDM 3D printing across suppliers and colors and materials on a level that no one else has ever really done before. And this Tensile testing machine is the start of that. Once this kind of hits rhythm, then we'll start introducing like UV testing and fatigue and all those kind of other factors as well. But the main goal is to just start getting information out about how 3D printed parts behave, both in highly quantifiable ways around like ASTM, which we're going to work towards, because those metrics are very useful for purist engineering, but they're very non-useful for helping people build an intuition. The first thing we want to do with Tangled testing is help people build an intuition about what 3D printed parts can do and what they can't do, so that they can just be like, oh, yeah, they whacked it with a hammer, so I can whack this part with a hammer and it'll hold up fine. Then we can refine it down to, I need a 10% engineering margin on this part, what infill do I need to use? That kind of thing. So Tangled testing will start ramping up. We're also working on getting another video editor in to help with the Tangled testing channel, because with this core channel and with Tangled testing and with all the other content that we do, both around education and product prep and all the rest of it, it is stretching the team a little bit thin. So we're working on getting that caught up. Okay. Oh, and that's actually a very good lead-in to the discussion topic of the day. Why are we not dead yet? Okay, so some color for this. As far as I am aware, we are the only print farm. We are the largest Service Bureau FDM print farm on the planet. There are other print farms that are similar-ish size to us, like 100 plus machines. Still smaller, but similar sized. There are similar other organizations around that use a lot of 3D printers. All of those organizations, though, focus on a single, let's say, category of product or group of products. So you have like Gantry and Prusa and here on YouTube, guys like Shop Nation and Out of Darts and that kind of stuff, who focus on a particular niche of products, and printers enable flexibility in the design of new versions and iterations of the products and new SKUs but they don't have to deal with, quite frankly, just random stuff coming from above. So like with our Etsy application, we have people making cookie cutters and people making, well, Nerf mods and people making functional planters and that kind of stuff. And all of those are very different types of parts. So we have to have a system that is robust enough to take anything and still produce a good result so people aren't mad at us all the time. It's even more difficult on the client side because a client will bring us, I need this super high quality part and piece that can have no defects versus I need 10 million brackets for my furniture company. That and I don't care what they look like so long as they're functional. Knock them out. That's the range of stuff that we have to deal with. And that's very, very difficult because while it is still vastly more flexible than molding, we still have a lot of prep and engineering work to do on any new project that ever comes in. And it can be really difficult in that regard because it's so disparate what can come through our doors. This is why most service bureaus, quite frankly, this is one of the fundamental problems with service bureaus. And we've talked about this on the channel before. Print farms and print service providers are a terrible business because you're killed by death of 1,000 paper cuts to where it's very difficult to be so good at everything to where people can trust on you. And quite frankly, even we're not. This was actually really interesting. The other day I was reading a book about, it was Warby Parker, and they were buying some frames of glasses, and they had one manufacturer, and they bought like 10,000 frames from him, and they were a little bit out of spec. And in the book, they just say, oh, so we had to eat that cost and move on to the next thing. I underlined that line when I was reading it. The book, by the way, was called the Billion Dollar Brand Club. Billion Dollar Brands. Just Billion Dollar Brands. It's a very good book. I recommend it to everybody. But they were talking about these different direct-to-consumer brands. Anyhow, Warby Parker ate the cost of the pieces being wrong. And I underlined it because when we screw up, we eat it. Every time. So long as it's our screw up. Now, there's sometimes a client will have us say, make this part, make it as fast as you can, get it to us. And then they get the part and they're like, this isn't what I wanted. And we're like, you didn't tell us what other stuff you wanted. There was no way we could read your mind, which by the way is another problem with a service bureau. Clients have to provide enough information to where we know we're meeting all their specs. And many clients, especially in printing, where a lot of them are startups, do not know how to spec a project. So we go through and we try to qualify them and get all the information we can by asking questions. But still, since each project is different, not all the questions overlap and we can't just have a script for it. We just got to poke at it of like, what are you doing? What are the goals? What is like a critical dimension? That kind of stuff. All those kind of things. So it's very challenging. But we take it. We take it in the teeth when we screw up. If we indeed screwed up. Like, did we ship you parts that were bad? Like, oh yeah, somebody that day had an off day and they threw a bunch of half-finished parts into the box for some reason. Humans make errors and we produce a lot of pieces, so it comes up. We replace those parts free of charge. But reading that, I have never heard of another manufacturer who did it. And I don't know if there's just so many of them around that people just say like, it was in Mexico or it was in China and you just deal with it. As a U.S. manufacturer, I don't think we're allowed to. Well, no, we are allowed to because I get screwed by suppliers all the time who are U.S. based. But you shouldn't. But it's really, really brutal to deal with that because when you do so many disparate projects and you're trying to read the mind of the client, it's a very high probability that stuff can go wrong, quite frankly. You do everything you can to minimize that probability, but it comes up a bunch. And it's a giant risk factor to print farms. If we make 1 million parts and the truck shows up and all those parts just didn't work or something, we generally say that's our fault. It's our job to get final good parts to the customer. Anyhow, that is a giant risk of printers, farms, but that is why service bureaus don't exist, because it's very difficult, super painful, and super dangerous because of that. We have a few other ways of protecting ourselves, and I'm not going to say diversifying, but broadening and focusing ourselves intelligently. But we are the only print farm service provider of our scale that I am aware of. There are other print farms around, and there's guys with 20, 50 machines around who will definitely take a job from somebody on a regular basis and produce a couple thousand parts. But no one on our scale. And in fact, the last one that I knew of went out of business in like 2021. And every large print farm has gone out of business. We're like blimps. Every one of us has crashed. And where's the Hindenburg? And we're hoping that we're going to land in New Jersey, all right. But the reason many of the others have failed is that, number one, since 3D printing was a digital technology, digital technologists thought they could grab it and say, it's a software problem. It's not. It is vitally important to understand that you're in the hardware game and you're in the manufacturing game, which are very different from software in that they're not free to copy and replicate. Also, things like depreciation matter and all that kind of stuff. Depreciation matters in software too, but it's less directly monitored because software doesn't appear on a balance sheet. Like content doesn't show up on a balance. It's really weird how accounting works. Things of value don't have value, and things that do don't, and so on and so forth. I don't know. But the challenge of having most people who are interested in 3D printing be digital technologists rather than physical or manufacturing technologists sets them up for failure because they don't realize how nasty it is. And you can see this actually with developers when they're working on physical product applications. There is a disconnect because code is in a perfect world. Code exists in a perfect world. And while many developers out there are screaming and saying, I've gone through integration hell, I'm like, no, you haven't. Unless you have had to send your code through a USB hub to communicate with another machine, you have no idea how terrible software can be. Because now you're dealing with the intermittency and the messiness of physics as soon as you try to control physical reality with software. So there's a mindset problem there for digital technologists moving into 3D printing, which sets them up for it. There's all the normal problems of companies failing. 9 out of 10 companies fail because somebody steals, somebody's selfish, somebody's mad at somebody else, or you just didn't file your taxes right that year, you got sued or whatever else it was. Just business happens and you don't succeed. I've seen many of that. There was one startup that was going out of business a few years ago, and they reached out to us to ask if we wanted to pick up the bones. And we looked at the books, and I was like, the reason you guys went out of business is because you have 7 founders who all make 6 figures. That's why you went out of business and burned through your startup funding. And I was just like, well, that was an easy fix. But there's a conversation to be had around growing quickly and spending a bunch of money and surviving and being miserable for a long period of time. There's pluses and minuses to both. In business, it's very much a survival game, so long as there is still growth attached to it. You don't want to be flat and surviving. At that point, you need to take it out in the back and shoot it. But for us, we have never been a non-profitable company. I am extremely stringent that projects have a roadmap to profitability within a couple months. Like, we're going to do A, and that's going to generate that many dollars, and it's going to pay for A. So that stringency has allowed us to take small bites of the elephant that is 3D printing, and also make sure that we're very metrics focused. Like, does this work or does it not? Well, we spent the money, we did the thing, it didn't make any money, killed it, moved on. We have a whole video on the channel talking about projects that we killed because they did not meet this metric. And you don't throw good money after bad. If it is not showing promise, then it doesn't get any more money. And as a bootstrapped organization where we can only eat what we kill, you're very careful with your money. So you don't make big stupid bets either. And you hold people accountable much more readily because like the money disappears and then it's not there anymore. So we've been able to survive because quite frankly, we're just exceptionally scrappy, even for scrappy startups. The other thing that I think has been a huge strength to us that most service bureaus have never done is a big focus on standardization, which is well understood inside of manufacturing, but again, not well understood inside of 3D printing. Inside of 3D printing, especially in service bureaus, people believe that adding more options improves the business. And it's not the case. It's very rarely the case. If that was true, Apple would make smartphones and TVs and, well, they make their chips now and that kind of thing, but that didn't used to be the case. Apple has grown to where they can make their own chips, and it's not a big lift to do that, but they didn't do that on day one when they were making the iPod or the original iMac. They were reliant on suppliers. But extreme focus on our part of being only FDM of a particular size, FDM within particular materials. We never chased high temp. We never chased large format. Well, no, we did chase large format for a minute until it didn't hit metrics, and then we killed it. And we've never chased other tech. We keep a bead on other stuff, but we never had any interest in powder. Resin was tested very early on in the early days, but fundamentally we believe that resin isn't really the right technology for what we're trying to do here, which is build a warehouse where the shelves make the product. Resin doesn't do that. So being exceptionally focused, very cogent of where the money was going, and ensuring and being very stringent about having to have a return. Like even within, a good example is this YouTube channel. Like this YouTube channel exists because it pays for itself. When we first started doing videos, we had about we first committed to making like a video a week. Of like, we'll commit this much time to making a video a week that is useful to clients and educating people, and we can use those videos as corporate training and the rest of it. But people ended up watching them. And as we saw that views increased and lead generation increased, then we continued refining it and reinvesting into it. So we started doing 2 videos a week and then 3 videos a week. And last year at our peak, we were doing 7 videos a week. Right now we taper back to 3 core videos a week plus podcast when we're around. I was gone last week. I apologize again. I was down in Austin. We're working on stuff. If you follow the channel closely, you'll know what this stuff was. But anyhow, being super, holding ourselves very accountable in the fact that we're a business, and in order to survive, a business has to make money. We are not one of the startups where you get $10 million and you go spend it and build a thing and blitz scale and all the stuff and get your network effects and buy all the Facebook ads and make sure you're on the cover of Forbes. We never did that. In fact, quite the opposite. We've always been very frugal and surprisingly low-key and under the radar. We've never really officially been in stealth. But I would say that we keep a low profile for what all we do, because we do a bunch. Within the context of focus, it's very easy to make the argument that Slant 3D is a very unfocused company. We have Tangled testing. We have a YouTube channel and associated media stuff. We, of course, do mass production printing for production clients. And then we have the software stack, which is like the Etsy integration and those kind of things where we help the e-commerce clients. We have our own individual e-commerce products through like Angled. And, of course, Tangled has now joined, and with our own internal filament production. We manufacture our own machines. We're very vertical. That is a terrible decision for a startup. You do not want to be vertically integrated as a startup. If you are a seed stage company and you are saying one of your competitive advantages is that you're vertically integrated, you are going to die. You have an exceptionally high probability of dying because a vertical integration just means you have 5 companies inside of one. That's all that means. If you can survive it, it's great, but you don't get to use it as a competitive advantage at the beginning. At the beginning, it is a competitive danger. No, it's not a competitive danger. It's an operational danger because you have 5 things that all take resources and are all necessary. I would love for Slant 3D to do less, but we can't because like suppliers can't keep up with us. The cost of material is too expensive and nobody makes a machine that we can use and so on and so forth. So we just do it all. So, but while we are very vertical, each one of those verticals that has been added has had to prove itself. So like the YouTube channel had to prove that it could either generate leads or generate ad money. And it has done both. So that we're now able to create free, good quality videos that are really educational for folks, but they are serving a purpose that is monetizable within the company. It has to, otherwise it's unsustainable. Tangled Testing was bootstrapped with a Kickstarter at first to kind of give us seed money for the machinery so that we knew people wanted the stuff. Slant 3D itself started with 10 machines and a Littlebots project, which was also a Kickstarter project that grew from there, but funded all the machines. We are very minimum viable product, prove that people want it and prove that you can make money from it, and then grow from there. You iterate and you grow and you improve. I don't know of a project off the top of my head where we heavily invested for long periods of time on a version of it and then released it 6 months down the road. We never did that. I would say that software is one of the bigger investments that we've made, but it's been over multiple versions. And quite frankly, we've had multiple bites at that apple, and we've screwed up multiple times. In fact, we've hit every stupid branch on the way out of that tree on software, but we're doing really good now. But the process of getting there and getting the team together and getting the product built correctly and usefully has been a long road to hoe, and a quite significant investment compared to many of the projects that we've done historically. But software is really important because if people cannot access the print farm easily, no one other than 3D printing people will ever use it. It's so vitally important for us to become a warehouse where the shelves make the product that people are able to access the warehouse from wherever they can. Like if we want to teleport stuff around the world through our print farms, it's got to be easy to use us. So software is just really important within that regard. The full stack of it, but it's high risk and super expensive. And right now, not profitable. But again, it's one of those things that is obvious and necessary that has to be created regardless of how brutal it might be. So we figure out ways of getting it paid for through other means. But yeah, the reason we're not dead yet, I would say, is that we just are very, very accountable that things are useful. If you have something useful, then it is inherently profitable. There's nothing I can think of that is useful that cannot be profitable. So there's just that high level of accountability, focus, measuring stuff by how many dollars it brings in. That has all allowed us to survive to this point and continue to grow. And we'll continue to use those principles into the future, which is just be very frugal, hold yourself accountable, make sure that what you're doing is something that's useful. And then if it's not working, be truthful about that and kill it, which is we've done many times before. On many ideas, it would have been great, but you have to be humble enough to say that your idea was wrong and bad. And that can be really tough for people because if you've worked really hard on something and it would be awkward right now if I found some new information that said that 3D printing was stupid and obviously wasn't going to work, to where I would have to make the decision to just shut down the company. That would be a stupidly hard decision. I've done this thought experiment before, and if somebody could prove to me that they were absolutely doing the better than us, and I did not see a roadmap to where we could match them and survive or something like that, then we would shut down the company. But we are right. 3D printing is definitely going to change how the world makes everything. And it's our job to make sure that we continue to survive, to find the flavor and the implementation that actually meets that expectation. And for us, it is print farms. Print farms are the right way to mass produce items and produce customized items on demand. They just are. Everything structurally about it implies that. And again, I'm not going to go into that conversation because we've already gone a long time on this one. But yes, 3D printing will keep on going. So we're not looking to shut down anytime soon. But we've been able to survive because we're just very disciplined, very focused, very frugal, and very accountable for everything that we do. Hopefully that was useful to y'all. I don't think there's anything else. We'll let it go right there. Have a great day, everybody.